Stop, go ahead. Fast.
My name is Akiyoshi Yukioka, and I'm 10 years old, and I go to Lakeshore Elementary / Tyson Middle School. And I have 1 year of FLL experience, and my role this year was a project manager and builder. As a project manager, I made a Gantt chart with help from Haruka and my dad, the coach. The main tasks were building and programming. We could not program the robot until we finished making the robot, so we built it first. And we finished on schedule. This is a prototype that our coach showed us. What this does is it moves the arm while it keeps the platform steady. This was later changed into this. What this can do is you can sweep back
Akiyoshi, put in here.
You can sweep back game pieces, or we can detach the sweepers and attach tape to the front for barrels, or we can attach tape to the bottom for the pond alligator. Haruka created the programs. We decided to put 4 tasks into one program slot with 5 seconds in between each program or mission. It included the base frog, and the golden frog, and the golden alligator, and then the base alligator. Our program 1 included the swamp dance. Program 2 included the left top barrel. Our program 3 included our top right barrel. And our last one, program 4, included our pool alligator. For the pond alligator task, we noticed that if we needed to attach tape to the bottom, and if we attached a certain kind of tape, it could not pick up the pond alligator. So, we needed to decide how we can improve the design. To make a decision based on data, we did something called Design of Experiment, or DOE. For the DOE, our control factors were tape direction, tape kind, number of lights, number of tape rolls, direction of object, hold time, up speed, and size of platform. We also had 3 error factors which you cannot control. There were temperature, wind, and vibrations. For the temperature, to mimic the temperature we used a hairdryer, to mimic the wind we used a fan, and to mimic the vibrations we used an air compressor. If we were to simulate every single factor, we would have to do 34,992 experiments. Using the DOE, we were able to reduce the required experiments to 72 cases, or 18 experiments, with 4 factors each. Our measurement result is on this table. For this experiment, Haruka held and shook the DOE mechanism, and I timed it. For an example, test number 14 shows that the game piece can be held for 16.1 seconds under room temperature with no wind and no vibrations. But if we add the wind and vibrations, it could only hold it for 7.6 seconds. And if it went over a minute, we would put 60 plus and we would terminate the experiment. Using the measurement results, our coach did analyzation, and the analyst results are shown on this table. On this table, the optimized factors are shown in blue, which are tape direction, horizontal, tape kind, blue, weight, 4 blocks, row count, 2, direction of object, diagonal, hold time, 3 seconds, up speed, fast, size of platform, medium. Also, this table has a column called contribution. The higher the contribution number, the more important it is. For an example, the size of platform was 25, which made it very important. But the tape direction was only 2.7, which made it not so important. So, if we were to change the size of the platform, it would affect our robot's performance significantly. But if we were to change the tape direction, it wouldn't make such a big difference. When we do the DOE, we need to validate if the optimized conditions are really optimized or not. We did a validation test, and this table shows the validation results. As you can see, every result shows 60 plus per second. Thus, we can conclude that the optimized results were really optimized. And these are the highlights of the robot's design. We have an extra line follower sensor in the back. We also have a counterweight in the back to even out the weight from the front. If we did not do this, it would go up and down and tip forward and down, and we cannot count the ticks correctly. Our sensors for the encoder is glued, hot glue gun, and a foul down mega blocks. We did this because if we thought we just hot glued it down to the spot, it would not be stable. We also have a case for our battery pack, because if we did not, it could not fit. We also have an extension cord, because we put it this way, it could not reach all the way. And we could not put it this way. Our arm moves up and down because of the servo motor is attached to a piece of wire in a hole in this mega box that was drilled in by a drill bit. Thank you for listening to my presentation. Any questions?